Hi, everyone. Today I will be talking about the activity of glycogen phosphorylase B with the use of various effectors. I want to apologize for not having my camera on. I'm not too sure what's going on Zoom. But yeah, so glycogen phosphorylase B is an enzyme used when accessing energy. In vivo, the reaction takes place where the enzyme cleaves off a glucose to be used for oxidation. But what's really interesting, though, is in vitro, glycogen phosphorylase B can act reversibly, where glucose 1-phosphate is added to glycogen and releases an inorganic phosphate into the solution. Thus, we are essentially testing the activity of enzyme through its organic phosphate production. This is done by having our stopping reagent contain moldbate ions that can complex with the phosphate ions to turn the solution into a deep blue, which is used to record the absorbance using a spectrophotometer. And so the first two graphs you see here serve as standard curves. Graph A shows absorbance values of inorganic phosphate at various concentrations, and graph B shows the absorbance of inorganic phosphate formed without the addition of the enzyme. This will be used to aid in the data when using actual effectors during the experiment. And as you can see, with an increase in phosphate ion concentration, there seems to be an increase in absorbance, and there also seems to be just a natural increase in inorganic phosphates with an increase in substrates. But on the left here, I tested 3 different effectors: AMP, epinephrine, hydrochloride, and a 5-hour energy. While the results were somewhat varied, there are general trends that can be seen throughout. Graph A tests AMP as an effector, and as you can see, as the concentration of AMP increases, the activity begins to increase as well. And this is just comparing the 0 AMP to the other values, but it does seem that there is an increase in activity. For graph B, epinephrine hydrochloride decreases the activity of glycogen phosphorylase B, producing less phosphates. And as you can see, 0 millimolars is kind of at the top, and then 4 millimolars is at the bottom. So there does seem to be a decrease in activity. And then lastly is graph C, which is the slight increase in concentration of 5-hour energy, depicts kind of a decrease in enzyme activity, but because the concentration differences are just so small, it's really hard to tell. But from this, we can see that AMP may serve as an activator for glycogen phosphorylase B, while epinephrine and hydrochloride and while epinephrine hydrochloride and 5-hour energy serve as an inhibitor, which may suggest how glycogen phosphorylase B acts in environments of low energy and high energy. For the future, I would like to redo my assay for the 5-hour energy to increase the concentrations, potentially find ways to isolate the ingredients separately from the 5-hour energy, conduct statistical analyses of the current assays also, just to make sure that these are statistically significant, and also conduct assays with both activator and inhibitor in equal molar amounts to see how that affects activity. But that kind of wraps up my presentation, but I would like to acknowledge the help and support of the De Guzman lab for everything. And yeah, thank you all for listening.